For my first recap video on iterator reliability, we're going to look at one specific way to measure that, and that's with a point-by-point agreement. This is used for things that are frequency counts, but not necessarily something where multiple raters, you could code it multiple ways. So if you had set instances where you would say, you would kind of label them as being like correct or incorrect, you could use Cohen's kappa. But in this kind of case, if I just had a video and I wanted a rater to code, for example, in this case, just every time a student had a correct response. So I thought I would start with something nice and simple like that. You would need to use something like a point-by-point agreement, because I would want to know if we coded the same responses, or if there were any extras that one rater coded that the other one didn't code. So I'm going to kind of take you through this little process here. I'm going to begin with the code windows. I have one code set on for each of these, and if you notice, my code windows look exactly the same for my two coders. I just changed the color a little bit so it would come up differently on the timeline. But I have correct response, and in parentheses I have a 1, and then I have a 2 over here. You could use initials, you could use numbers, it doesn't really matter. And something you could think about is if you actually had you made an entire code window that's, a lot more complex than this, you could just copy and paste the whole code window over and do a simple files, edit, a find and replace, and look for all parenthesis 1s and replace them with parenthesis 2s. So you could very simply duplicate your code window for multiple coders. So I'm just kind of starting bare bones, simple here. I have a code, and the first thing I want to point out here, when I open up my inspector for this code, because I'm not looking at duration at all when I'm looking for frequency counts, I want this to just turn on and off on its own. So I'm going to first set that here by adding a custom lead time and lag time by checking these two boxes. I gave it 2 seconds on either end, so I have pretty steady size instances over here. So these numbers, how long your lead time and lag time need to be, will depend on how frequent a behavior is. So you might need to look at a video first to see how frequent it is. If it's very frequent, you're going to need very short lead time, lag time, or you won't be able to code each one of those. 2 seconds seem to work about for this one. It also depends on how quick an instance is. So ideally, you don't want it to be too short, because otherwise there could be a little bit of error in terms of when I press the button and when coder 2 pressed the button. So I just kind of picked 2 seconds either way for something that kind of made sense for this particular video. And I can see I've already, fake coded these for coder 1 and coder 2. When I stretch them out, they're pretty close, but you can see they're pushed off just by a little bit. They're not, I didn't start them and stop them exactly at the same time. It's like 4 and 5 here. I can see they're just a little bit off. And I purposely, when I went through this video, I purposely left a couple out. Coder 2 tagged things that included like prompts for, give me a high five if he got it right. And coder 2, in this case, counted it as a correct response if the student correctly gave a high five, whereas coder 1, because it was a praise, didn't count it. So I kind of made a fake scenario, and this would be something that you'd want to do before your study to say, oh, do we both have that operational definition down? And you need to decide what an appropriate iterator reliability is for your study. Generally you want at least 80%, but it depends on what type of behavior it is. There are a lot of ifs, and that's something you want to research for your, look into other sources for your own research. So here are my timelines. You can see that we're not going to have perfect iterator reliability, because I can see, while looks like we coded these correctly, there are some that Rater 2 has that Rater 1 doesn't have, and then there's one extra at the end that Rater 1 coded and Rater 2 didn't code. So I clearly won't have 100% iterator reliability here. So that's the first thing to consider, that you want that lead time and lag time. I'll go back over here. There we go. So that's something to think about. Make sure this isn't checked, reactivate lag time. That means as soon as it ends, it'll start it up again. We don't want that for this particular case. So the way we're going to tell the actual program, to count whether or not we counted the same incidents, we're going to look to see basically do our instances overlap with each other? So I'm going to be writing a command in my script that says count all the times where our instances overlap one another. Okay, and I'm going to show you that code right here. So this is a box that I made. It's the same thing on both Radar's code windows. So we just need to look at one of them. This is just my output box. Okay, and I called it point-by-point agreement for inter-rater reliability, and then this red part is my output. So when I'm looking at this, first thing I need to do is to make sure the show output button is checked. So otherwise, if I didn't have this checked and I went back, you wouldn't see any kind of output here. So that needs to be checked. And you can decide what the default output text is. I think it might come up as a question mark right away if you haven't, if you have no data. But I like to switch it. I think the dash looks a little nicer. That's your choice. Now this $S looking thing over here is the script part of the inspector. And this is, I'm going to kind of break this down for you because I know I briefly talked about this earlier, but I didn't really break down the formulas that I used. And a lot of people in the webinar I just did, a lot of people were asking me about it. So I thought I would start with the simplest form of inter-rater reliability and show you my scripts for that. Okay, so let me open this up a little bit more. What's nice, if you've never done scripting before, you can kind of, like, sometimes I'll make a script a long time ago and forget what I was making it or what I meant by it. So if you use like these little railroad tracks, just 2 slashes in a row, that tells the program that anything after that is just a note. It's not something that's actually part of the script. So I like to put notes for each kind of step along the way so I know how I'm calculating it. Then if I find an error, it's easy to kind of go back and find where that error is. So first thing I want to do, I want to set some variables because it's easier to do some of these calculations later down here when you've already defined variables. So I want to count the overlapping instances first. So I just defined it as $AG, meaning agree. And you'll see why in just a second. I didn't use the whole word agree yet. So this is my first variable, $AG. And I'm asking it to count all the overlapping instances where the row says correct response 1 and the row says correct response is 2. So basically, I'm telling it count all the times that these are overlapping with each other. That's why that lead time, lag time is important, because if this was over by too far, it wouldn't be the same instance. It wouldn't count it as overlapping. By giving a little bit of lead and lag time, you leave a little room for error, but we still understand that we're coding the same instance, because clearly I might have pushed it at the start of him saying the correct answer. You might have pushed it at the end. So for frequency counts, lead time, lag time works great, and it can avoid some error in your inter-rater reliability coefficient. So the only issue with this when you have count instances, it's going to count each of these as separate. So even though I can see this is 1 overlap, it's going to count this as 2 because it's counting 1, 2 instances that overlap. So what you have to do to get the true number of, codes you have in common is to divide that number by 2. So that's why I have $agree. So this number, $agree, is going to tell me how many times we coded the same instance. So hopefully you've followed me up until this point. So that's the first step. Now I need to look at how many instances coder 1 and coder 2 coded that the other one did not code. So I want just Rater 2. So like this, I want to be able to count this instance here, number 7, and number 14. And then for Rater 1, I want to count this one here, just one floating instance on the over here. So we agreed on a certain number, and we disagreed on some others. So I'm going to calculate it for each Rater. All right, so here's my little note again, frequency count of instances, only Rater 1 coded. So $Rater 1, that's the variable I named here. I tried to just use $1. This is just a little side note. Apparently when you're naming variables, don't start with a number, start with words. I could not figure out for the life of me why I couldn't get the same script that I've used before to work. And that's because I tried to name it with a number. So start with letters after that $, and you won't get error messages. So $Rater 1, I'm asking to count all instances that Rater 1 coded, and then I'm subtracting all the ones that they agreed. That's going to give me the leftovers, just the ones. In this case, it'd just be 1 because they agreed on all the other instances that Rater 1 coded, except for this one over here. So that's going to give me just Rater 1's extras, just Rater 1. then I'll do the same thing for rater 2. I'm going to count all the times that rater 2 coded it and subtract all the agreed instances, and that's going to give me the leftovers that's just rater 2. Now, a formula for a point-by-point agreement, I want to know, it's the total agreements here divided by the total number of instances counted. So that total number is going to be all of the agreed upon instances plus all of just rater 1s plus all of just rater 2s. So you see that's going to give me the whole total for the bottom. It's all the different ones. So basically it's the agreed and the separate ones. So my point-by-point agreement, iterator reliability, I've named a new variable, $IRR, equals the agreed upon divided by the total number that either one of them coded times 100. Okay, and it just, use parentheses the same way you would in like an Excel program. Now, to get an output to come out, you use the show command, and each script box can only have one show command. So here it is at the end, and I like to name things as variables because it makes my show command nice and neat. I'm saying show, I want the words. Anytime you want words to come up, like see how here I have the words IRR equals. When I want that to happen, I have to put it in quotes. So I'm saying show IRR equals, and I left a little space after the equal sign. So otherwise, my number will be pressed up against the equal sign. So I want IRR equals space. Plus, I'm using an extra command in here, which you don't have to. It just makes it so it's like a neater percentage. I'm rounding this variable, iterator reliability, to 0 decimal places. Okay, so I can round it very easily to 1 decimal place like this. And I'll even change that so you can see what it would look like. And then plus, I want to put a percentage sign at the end of it. Okay, so that's going to give me my show command. Now, if I hit, I haven't extended this very big. I'm going to hit execute because I've got my code window kind of tiny. It's going to calculate 76.5%. That's my iterator reliability using a point-by-point agreement method. And that makes sense. Looking at here, we clearly didn't agree on everything. There were several that there was some disagreement on. And generally, if you were doing this as part of a training phase, you would probably say that 76.5% is not sufficient for your training. So that means you would probably want, redefine and retrain people, your coders, ahead of time. So that is method 1 of iterator reliability. Stay tuned. In the near future, I'll be posting about doing percent agreement for duration counts. And then something new for me, I think I'm going to try to come up with a new scenario so we can try to do Cohen's kappa, which is for specific kinds of situations for iterator reliability.